So the next topic we are starting with is logarithms. Okay. The fundamental of logarithm is that whenever your exponents get too big, that is something like you have 2 power 22 and you need to use this in a calculation. You're not always going to compute the whole thing and use it. So to reduce such huge numbers to small numbers for computational purposes, we came up with a system called logarithms. So whenever you have, let's use the exact notations that you have in your textbook so that we won't be confused. Whenever you have some a power x is equals to n, you can write x, you can convert this into x is equals to log n to the base a. This is logarithm of n to the base a. That is how it is called. When you are converting, the base here will always become the base in the logarithm. You are trying to find out the value of the exponent. So x will be your LHS and your answer will become the number that you are trying to find the logarithm of. So for example, if I have 2 power 4 is equals to 16, this can be written as 4 is equals to log 16 to the base 2. All right, does it make sense?
Yes, ma'am.
Yeah. So this conversion is something that you should be able to do pretty easily. So let's see 2 to 3 of these things. I have what is the logarithmic form of this? Nida, tell me what is the logarithmic form of this? This is called the exponential form. Note this down, this conversion. Then look at it and tell me the answer for this. Noted it down?
Yes, ma'am.
Now tell me.
4 is equal
Hmm?
log 625 log 5 to the power 625.
Log 625 to the base 5. There is no power in
To the
logarithm.
base. Okay.
To the base 5. Okay?
Okay, ma'am.
Super. Nandini.
Three is equal to log 10.
1000. 1000 will come first. 1000 to the base
To the
10.
base 10.
Base here will always be base here. All right? Now we'll do the other way around. What is the exponential form of this Mamata? Again, did you note this down?
Yes,
Tell me.
ma'am. 20 20 20
Hmm.
to the power of 2 is equals to 400.
Right? Even if you actually did not know, then you know that within these three numbers, 20 square is equals to 400. Right? So this is how the conversion works between exponential form and logarithmic form. Keep that in mind so that whenever in a problem you're comfortable with exponential form, you'll be able to easily shift to that side and solve the problem. All right. Like the various properties of numbers that we saw for exponential form, we have some for logarithmic form also. So the first one is, there are some ground rules. Whenever I'm just writing log 15 and not specifying anything, that means it is to the base of 10. The standard base is 10. Whenever he is asking to convert to a standard base, or he's giving random numbers like this, like log 2, log 3, if he's giving values of them, that means he's asking about log to the base 10. Okay, that is standard base. All right. So here also it goes without saying, if I write or let's write with this. Okay, sorry. Like in exponents, here also operations can be done on logarithms only if the bases are equal. There you can multiply only a power m into a power n only when the bases are equal, right? Here also it's the same. Only when the bases are equal, you'll be able to do operations on the logarithms. All right. So my first formula is log m to the base a plus log n to the base a is equals to log m into n to the base a. All right. So we'll see some examples of that. What is this equal to?
Log 6 base 10.
6.
10 log
Log 6 base 10. Right? So before this happens, we'll see few of these and then we'll jump into the problems. Second one is log m to the base a minus log n to the base a is equals to log m by n to the base a. All right, in that one, when you are doing divided by near the basis, you are going to subtraction in the exponents. Here it is the reverse. If you are doing, if there is a negative between logarithms, you have division in the inside the logarithm. All right. So again, how much is this equal to?
Log 5 base 10.
Log 15 by 3, that is equals to log 5 base 10. Right? Third one is kind of an important property in logarithms. Log m power n base a is equals to n into log m to the base a. This is the thing that we used mostly to reduce the number, to reduce the competition, because your power will come to your product, so you can easily solve a product rather than do power so many times, right? Something like log 2 to the base 10 whole power 30. How much is this equal to?
Log 60 by to the base 10.
Log?
60 to the base.
No, you are not doing m into n. Okay, your n comes to before the logarithm.
30
It
log
becomes
base 10 to
30 log 2 to the base 10. My base is not changing at all. Okay, this is 30 into log 2 to the base 10. All right. Then if you know the log value of log 2, this is your easiest problem. Instead of doing 2 power 30. Right. So your power becomes the product. We'll get to see more of this when you're starting to do the problems, the applications of this. All right. So keep these three in mind first when you're doing the problems. As we start adding more, as we start doing more problems, we'll write down more formulas we come across here. All right. So using whatever you have known now, the three formulas that you know till now, let's try to solve this problem. Tell me. Can you solve this for me quickly? First of all, check whether the bases are equal. If the bases are equal, then try to do the problem.
log 4 base 10.
Again, I'll write the value of log 2 to the base 10 is equals to 0.3010. So tell me the answer in terms of numericals. If you did get log 4 base 10, then using this, try to find the answer. What is the first thing that you'll do? Because you can't directly do negative on this because this has 2 in the front, right? Try to convert this into a normal logarithm using the third formula. So you have n log m to the base a, that is equals to log m power n to the base a, right? So what will this become? You're doing reverse of the formula. Your product in front becomes exponent of the question. Tell me, what will this become? First term.
Log 8 base 10.
Log 8 base 10. What happened to the 2?
Exponential.
This became 8 square. Okay. Minus log 4 base 10. What is 8 square? So I have log 64 base 10 minus log 4 base 10. Right? Log A minus log B is equals to Krishna Sandeepa?
Log A by B.
Log A by B. So 64 by 4 base 10. Right? 4 sixteenths, that is equals to log 16 base 10. This is the answer you should have given me earlier. Right? Now, log 16 base 10, I want in terms of 2. So what can 16 be written as? Bhavani?
2 to the power 4.
So log 2 power 4 base 10 is equals to, again, same formula. You're doing it in reverse now. Log m power n base a is equals to n log m to the base a. So that is 4 into log 2 to the base 10. Does it make sense? So what is the value of log 2?
0.2010.
So what is the answer for this?
1.204.
1.204. Right? So let's try another problem. Now you'll do it on your own. Tell me the value of this. Anyone?
Yes, ma'am.
Yeah? Tell me. What is the first thing you do? This is in the form of?
Log 2 square base 10.
Okay. So log 12 minus log, when I'm not writing base, it means that it is 10 automatically. Right? Very good. Log 2 square base 10.
Base 10.
Yeah? What is the next step?
Log 12 minus log 4.
Log 4.
4 base 10.
Yeah. Log A minus log B is equals to?
Log A by B.
That is log 12 by 4 base 10.
Base 10.
That is log 3 base 10.
Just
That is what I exactly gave.
0.4771.
Right?
Yes, ma'am.
So, unlike ratios, proportions, or indices, logarithms is something that I believe you haven't ever done till now. Did you have logarithms in school?
No, ma'am.
No? So, we'll go very slowly with this topic, even if it takes 2 classes, okay? Because after you look at indices, these formulas will seem very similar to them, and you might get confused while doing the problems, okay? So, we'll do a lot of practice in class itself, and we'll do very slowly. Is that all right?
Ma'am?
Yeah?
Yes. Ma'am, is that compulsory to put the 10 there, ma'am? Logarithm. In base. Or
In base, while calculations, if I'm not giving anything, it means that this 10 is irrelevant, as in it's a given that it is 10. But in while moving forward from the next problem, you'll see that my base will be changing, and we'll have one more method to solve the base, make this into a standardized base while doing calculations. So keep an eye on it, whether this base is 10 or not. If the base is not given, assume it to be 10 and do your calculations. But when you are given something like log 2 to the base 3 plus log 3 to the base 2 directly, then you have to look at what this is. All right?
Yeah.
Okay. So, because you asked that question, let's come to that also. When I have log m to the base n, my standardized base is always 10, right? So to convert it into a similar base for calculations, we do log m to the base a divided by log n to the base a. All right? Log m to the base n can be written as log m to the base a divided by log n to the base a. So if I have log 3 to the base 2 into log 2 to the base 10, what will this become? First thing, you have to bring all of them to the same base, right? So my common base is always 10. So this will become log 3 to the base 10 divided by log 2 to the base 10 into log 2 to the base 10. These both can be cancelled. So that equal to log 3 to the base 10. All right? Does it make sense?
Yes, ma'am.
Okay. In this conjuncture, okay, we'll write this in our list of formulas. Where is this? What is the logarithmic formula of this form of this? Anyone? Mamata? What is the logarithmic form of this?
Log
Log
1 to the power of base 2.
1 to the base 2. No power of, okay? 1 to the base 2 is equals to, what is the term that is left?
Is equal to
0.
0, right? My 10 power 0 is also equal to 1. Now what is the logarithmic form of this?
Log 1 to the base 10 is equals to 0.
Anything power 0, any a power 0 is equals to 1 only. Any numeric, non-zero numerical to the power 0 is equals to 1. So any logarithm of 1 to any base is equals to 0. So when you have log 1, it automatically is equals to 0. All right?
Yes, ma'am.
Log any 1 to the base a is always equals to 0. So because you know all of these things, what is log 1 by a? Oh, sorry. Log 1 by m to the base 10. What is this in the form of? Log of m by n to the base a. So this will become log m minus log n. So what is this equal to?
M log 1 base 10.
This is not in the power. This is in the denominator. What you are telling is log 1 power m base 10. Right? Log 1 by m base 10 is in the form of log m by n base a. So Nida, what is log of m by n base a? Look at this and tell me. Log m by n base a is equals to
log m base a minus log n base a.
So what will this become? What is m in this case? Come on, tell me.
The
Log. Tell the immediate next step. That's all. What is in the numerator?
log
Sorry.
1 base 10
Oh, 10 is there. Sorry. 10
minus log m base 10.
Because we are dealing with variables here, let's make it a. Okay. Minus log
M base
a. Right?
Yes, ma'am.
So what did we say? Log 1 is
0.
0.
so that is equals to minus log m base a. Now at this point, tell me, if I give log 2 is equals to 0.3010, what is the value of log 0.5? This is not 6.5, might look like that. 0.5. My known value is 2, right? So try to write 0.5 in terms of 2. What will this become? What can 0.5 be written as? 1 by 2. So log 1 by 2 can be written as
Log 1 minus
log 1 minus
log 2.
log 2. What is log 1?
0.
Minus log 2 is 0.3010. Right? Now we'll do this problem. I'll give you 5 minutes because this is the first time you are doing a logarithmic problem. Do it and unmute yourself and tell me. If you're stuck somewhere, also let me know. You don't need to get the answer.
Log 5 by 162 to the base 10.
Log 162 to the base 10, is it?
Log 5 by 162.
5 by 162. Where did 162 come from? But okay. We'll
Ma'am,
try to do
log,
that. Huh?
ma'am, log 5 by 9 into 18.
5 by 9 into 18. So what did that become?
162, ma'am.
Log 10, ma'am.
Yeah, right? Log 5 by 9 into 18.
Log
So
10.
log 10 is your answer?
Yes, ma'am.
All right, super. I'm very glad that we came there. So we'll do this. First things first, this will become my power of 25. This is in the form of n log m to the base a, that is equals to log of m power n to the base a. From now onwards, to make your formula easier, I am not going to say to the base a to the base a again and again. It is implied. Okay. So this is 25 whole power 1 by 2 minus, this also will go to the power, minus log 3 square plus log 18 will be as it is. 25 power 1 by 2 is log root of 25, right? Root of 25 is 5 minus log 9 plus log 18. Yeah? Log a plus log b is equals to log of a into b. So log of 5 into 18 minus log 9. Log a minus log b is equals to log of a divided by b. So log of 5 into 18 divided by 9. That gives you log 10 to the base 10. Now we have to find what the value of log 10 to the base 10 is, right? Because I want a numerical. Assume that log 10 to the base 10 is equals to some x. Because I know how to solve exponents, I'll convert this into exponential form. What will this become? Nandini? Convert this into exponential form. You know, right? A power x is equals to n. Then x is equals to log n to the
Log n.
base a.
Okay.
Now look at this and convert this into this. What is n here?
10.
10 is equals to
10x is equals to 10.
a is 10.
Yes, ma'am.
10 power what is my number here? N is equals to, is that right? Sorry, not n. Here, yeah, x is equals to x. So 10 power x. 10 power 1 is equals to 10 power x. If bases are equal, fill in that blank for me. If bases are equal,
Power
Power
should
should
be
be
equal.
Power should
same.
be equal.
x is equals to 1.
Yes, ma'am.
So my answer equals to 1. So I did this because everywhere that is the case. Log 2 to the base 2. If you want to find this value also, it will be the same. 2 power 1 is equals to 2 power x. When the base and the number are equal, it always equals to 1. Okay? Any log a to the base a is always equals to 1. Yeah?
Yes, ma'am.
Okay? Good. So now tell me this. Again, I have log 2 is equals to 0.3010. What is the value of log 5? I know the value of 2. So try to write 5 in the terms of 2. What are the other things that you know? This is to the base 10. You know log 10 to the base 10 also? What is log 10 to the base 10 equal to? We just saw. Log
1.
8 to the base 10. Super. So I have 10 and 2. What can I do with these both numbers to get 5? Ida, how can I use the number 10 and number 2 to get number 5?
10/2, ma'am.
Super. So log 10 by 2 to the base 10. You know what is log of a by b?
Log A minus B.
Log a minus log b.
Log B.
So log 10 minus log 2. I know the value of both of these things. What is my answer? Hey, someone. Only numbers you have to substitute and tell me, right?
Minus
0.6.
Log 10 is how much, Bhavani? 1 minus
1 minus
0.3010. This is 0.6990.
Yes, ma'am.
Is that, yeah? All right. So we'll move on to the next problem. Change the base of log 31 base 5 into the common logarithmic base. What is the common logarithmic base?
10.
10. Yeah, so find that out. How do you change? This is not even barely a problem. That is log 31 to the base 10 divided by log 5 to the base 10. We saw this formula, right? Yeah, that's it. That's all I'm asking for. When they say to change into common logarithmic base, that means you have to make the base equals to 10. Yeah, because you know how to do this now. We'll go to the next problem. Tell me how much this is. Always convert all the numbers there into common base and then start doing your operations. Okay?
Ma'am,
Yeah?
0.401.
0.401. Where did you get a normal number from?
I applied log value, ma'am.
Log value of?
Yes, ma'am.
Log value of what?
I mean, apply log value of 3, etc. etc.
Okay, okay. If that's the case, then I need to get answer around 1.2030. Okay, we'll start doing it. All of you, from what you have done, check where you have where you went wrong. Okay. So first things first, I'm trying to make all of them into standard base. So log 8 to the base 3 will become log 8 to the base 10 by log 3, right? This will become log 16 by log 9 into log 10 by log 4, right? Did we all do this till here?
Yes, ma'am.
Yeah, ma'am.
Okay.
Yes, ma'am.
Now 8 can be written as 2 cube, or we'll do another thing first. If you have A by B divided by C by D, my bottom fraction will become reciprocal and come to the top. You know that, right? A by B into D by C. Yeah? Are you
Yes,
aware
ma'am.
of this? Super. Sorry. So I'll write all of this in multiplication. Log 8 by log 3 into reciprocal of this, that is log 9 by log 16, and into reciprocal of this also, that is log 4 by, what is log 10 base 10? These are all base 10, right? Log 10 base 10 is equals
1.
to
1.
1. Super. Now after that, we'll start to simplify these numbers. Log 8 will become log 2 power 3 by log 3 is the smallest number. Log 9 will become log 3 square. Log 16 will become log 2 power 4. Log 4 will become log 2 square. Right? These are all in the form of log m power n, log m power n, m power n, m power n. Log m power n is equals to, Krishna Sandeepa, what is log m power n equal to?
Ma'am,
Log m power n is equals to
ma'am, M log n.
n into log m. Alright? Okay. So first one is log 2 power 3. That will become 3 into log 2 divided by log 3. Log 3 square will become 2 into log 3. Log 2 power 4 will become 4 into log 2. Log 2 square will become, Nida, what will log 2 square become? Log 2 power 2.
2 log 2.
Okay. Thank you, Mamata. This is 2 log 2. So my logarithms, except log 1, everything else is a positive number. So all of this I can cancel off. Log 2 can be cancelled. Log 3 can be cancelled. What am I left with? 2 2s are 4. What is left? Bhavani?
3 into
3 into?
1 by 2 into,
Where is 1 by 2?
no.
2 2s are 4 is cancelled.
Into log 2.
Into
Log 2 also
log
can.
log 2. This log 2 is cancelled, but the other log 2 is not cancelled. Okay. So my answer is 3 log 2. Now tell me one by one. Bhavani, where did you go wrong?
I did wrong in converting all the bases into same. Mama. There I
Okay,
went
so
wrong.
you did not do divided by?
No, no.
Okay. So the common basic for that is whenever you have a different base, you do divided by. Log m to the base n is equals to log m by log n. Okay.
Okay.
Mamata, did you go wrong anywhere or did you get the right answer? If you did go wrong, where? Which step?
Last second, ma'am.
Here.
Yes, ma'am.
So you had trouble with the formula of log m power n is equals to n log m. Is that it?
Yes, ma'am.
Okay. So practice, right?
Yes, ma'am.
Sandeepa. Krishna Sandeepa.
Ma'am,
Where did you have trouble and how did you get that answer that you got?
I done reciprocal, ma'am.
You did reciprocal. Then?
Yes, ma'am. In first step, log 310 by log 8 base 10. I took like that, ma'am.
Why? Okay. Oh, while doing itself, you took reciprocal.
Yes, ma'am.
Okay, so that's not the formula. Log a to the base b is always equal to log a, that is the top one, by log base b. Base should come in the denominator. All right?
Bit of confusion, ma'am.
Yeah, it's all right. So practice more. Nida,
Yeah, ma'am, the formula thing only.
which this formula or
log m n.
okay. So you need to do a lot of
Exponential form. Exponential
yeah.
form I did in this formula was confused.
Yeah, as you see, many problems that you have are based on exponentials only because for reducing a big number into small number, you always need to use exponential and take that power to the front. Okay?
Yeah.
So that formula you should be very thorough with. Okay? That's why I mentioned it also, right? When I was saying in the start that this is your most important formula. All right. Nandini.
That calculation.
Yeah? Did you get the answer or did you have trouble in any step?
In last step, that cancellation log.
Canceling. You did not cancel all the logs?
Yes, ma'am.
Okay. So logarithms are usually not usually. Logarithms are always positive numbers. Always, if you take a scale, let's say, if this is your integer scale or any rational number scale, I don't have a definition for log 0. Log 0 does not exist at all. Why? Because for log 0 to exist, you should have some a power m is equals to x. This x should be 0. Only then you'll have m is equals to log 0 to the base a. But except for when this base is 0, always this has a number. If your base is positive, always my exponential form will have a positive number. That's why log 0 does not exist with any base. All right. So whenever you have a problem called log 0 to the base 0, if it comes, this is not equal to 1 because there is no definition for log 0. All right. And for all the negative numbers also, if your base is positive, that means your base here is positive. If I have 2 power let's say minus 10, can this ever be negative? As long as your base is positive, you don't have any negative. You can't find the logarithm for any negative number. All right. There is no log of minus 1. So from 0 on, all of this side is off limits in logarithms. All right. Between 0 to 1, logarithm of all the decimal points between 0 to 1 are negative values. Any idea why? Because they are always less than 1. Because my log 1 is 0. So from here to here, all the values are, now logarithmic values are negative. From 1 onwards, all the logarithmic values are positive. All right. So you don't, except for log 1, nothing else is 0. So you can, if you have something like log 2 by log 2, you can cancel it off because these both are non-zero numbers. All right.
Yes, ma'am.
Yeah. Cool. Because earlier also we saw, right? What was log 0.5? Where did we solve that? I think I erased it. Was log 0.5 negative or positive? Log 1 by 2. That is log 1 minus log 2. This is minus log 2. So log 0.5, as we discussed in the scale, is negative. Any number, a logarithm of any number between 0 to 1 is negative. Log 1 is 0, and from then on, it's all positive. All right.